All right, so we're now moving on to the last section of this unit, and that's section 4D, and we're going to be solving a system of linear inequalities with two variables. So our objective and our goals for this video is just to be able to solve a system of linear inequalities. And honestly, this should be the easiest section of the four that we've done in this unit because we've already done solving or graphing linear inequalities before. And all we're going to do now is graph two separate linear inequalities on the same graph and look to see where their shaded region overlaps. So this really isn't anything new because we've already learned how to graph linear inequalities and we've already learned how to solve a system of equations where we look to see where they share the same answer. So there's really nothing new in this video. So this should hopefully be the easiest video and the easiest new section that we've done so far this year. And all we're going to do now is just go over two examples of graphing and solving systems of linear inequalities with two variables. All right, so the first example we're going to do is we're solving the system of linear inequalities, and we're given these two graphs. Y is greater than 1 half x plus 1, and y is less than or equal to negative 3x plus 2. So when we do this, all we're going to do is we're going to graph each of these graphs individually. So this first one I'm going to do in red. So we have y is greater than 1 half x plus 1. And remember, when we are graphing our inequalities, we treat them as if they are an equation. So we're actually going to be graphing y is equal to 1 half x plus 1 because we need to first graph our boundary line. And when we're graphing this, we need to first identify, well, what is our y-intercept? What is our b? And that's the constant. That's the number that gets added or subtracted to our variable. So in this case, it's 1, and that represents the point of 0, 1. So first I'm going to go and plot my point 0, 1 on my graph. Right? Then I need to identify, well, what is my slope? Well, my slope is the number that's being multiplied to my variable x, and that's 1 half. And remember, our slope is our change in y over change in x. So it tells us how we're moving from that y-intercept to start generating other points. So now it's a positive 1 and a positive 2, so that means I'm moving up 1 and to the right 2. So there's another point. I can do more if I want, up 1 and over 2. So once I go ahead and plot these points, I can then go ahead and draw my line. But the difference is when it's an equation, we don't have to think about anything. It's just a straight line and it's solid. When we are dealing with inequalities, we need to figure out, is it a dotted or a solid line? And this one is going to be a dotted line because it is not equal to and is just greater than. So you will use a ruler when you're doing this. I can't use a ruler on here because it's just really hard to draw a ruler on this pad or use a ruler with this pad. So I just went ahead and drew the best straight line that I could, but it needed to be dotted, right? And then remember, when we're dealing with inequalities, unlike equations, that's not our solution, right? We are creating two different boundaries, and now we need to shade in the correct boundary. And what we do now is we pick any point. And I always said it's easiest to plug in 0, and we're seeing, does 0 satisfy this inequality? So when we plug in 0, see, we get, is 0 greater than 1 half times 0 plus 1? Well, 0, 1 half times 0 is 0. So is 0 greater than 1? And the answer is no. So that means that 0, 0 is not a solution. So that means every other point in this region is not a solution. So then what we're going to do is we're going to shade the opposite region. Now, when you are doing this, I suggest that you use two different colors, or if you can use a pencil or a pen, or I'm going to show you one way here. I'm going to use lines for one, and I'm going to use circles for the other, so you can differentiate between the answers of the two regions. Right? If you have highlighters, it's best to just use two different color highlighters when you're doing this. But this right here is the graph to the answer and the graph of my red equation. All right, so all that black line region, would any point I pick in there, if I plugged into this original inequality, would satisfy and work. All right, now the next inequality I'm going to do in blue. So now I have y is less than or equal to negative 3x plus 2. Same thing, we're going to graph this as if it's y is negative 3x plus 2, so we can first graph our boundary line. Our b is the constant, so it's 2, so it's our y-intercept is 0, 2. So there's my y-intercept. My m is negative 3, and remember, our slope is change in y over change in x, so I'm going to put this over 1 because we know every whole number can be written over 1. So that means I'm counting down 1, 2, 3, and then it's positive for the x, so I'm going to the right for positive. Down 1, 2, 3, and then to the right for my x. And now I need to determine, is this a solid or a dotted line? And since it's equal to, it is a solid line. All right, so this is going to be a little bit harder for me to draw. So let me just go ahead and try and draw it the best I can. All right, so now let me just make this a little bit thicker. You will use a straight edge, but there's my boundary line that is true for the blue graph. Now I need to test the region. I need to see, am I going to color in the region to the left of it or the one that's above it? All right, so we're going to pick a point, 0, 0, and we're going to plug it in. Is 0 less than or equal to -3 times 0 plus 2? Well, is 0 less than or equal to 2? And that is yes. So now, instead of doing a straight line, I'm going to do a squiggly line and circles as my region, as my solution. And now, our overall answer is where both regions of our answers overlap. So you see this region here, well, I'm just going to mark it in blue. This region here is just the blue answers. There was no other straight line and none of the red answers were in that region. This region up here was just our red answers. There was no blue in that region at all. But this region included both the red and it included both the blue. So that means that this region, which I'm going to highlight in green, color in green, is our region that both of our answers overlap. So this region here is my solution. And when you guys are given your answers, you must make sure that you are exaggerating where your answers are. Because some of the sometimes when people will answer this, they don't actually signify what their answer is or what region, where their region is. So make sure you are letting me know that this region is your answer because it's the ones that satisfies both. So any point that I pick in that green region will work in either my blue or my red inequalities. All right, so that is one example. We're going to go through one other one, and then that'll be it for this. And in the second example, instead of using the same color for both, because that could be hard to see, I'm going to use highlighters because that's what I suggest that you do when you're answering these questions. All right, so now the next example we're doing is x is less than or equal to 6, and y is greater than -3/2 x plus 4. So remember, I'm going to do this first one in red, and we graph these individually. So we're first graphing x is less than or equal to 6, and we graph as if x is equal to 6. And when we have just one variable and not two, this is one of those special cases where it's either going to be a vertical or horizontal line. And since we know that our graph must include every solution for this x is equal to 6, because now this is what we're actually graphing, every single point on this graph needs to be where x is 6. So I'm just going to pick a couple points. Well, x can be 6 when x is 6 and 0, and x can be 6 when x is 6 and, let's say, 3. So I'm going to go ahead and plot those 2 points, 6 and 0, and 1, 2, 3, and 6 and 3. Once I have those 2 points, I can draw my graph. And since it's an equal, I know that this is going to be a solid line. So I will go ahead and draw a solid line going through those 2 points, so as a vertical graph. So this is my graph of x is less than or equal to 6. Now I need to pick a point to plug it in. So the point we pick in is 0, 0. Well, there's no y to substitute in for 0, but I can still substitute 0 in for that x. And is 0 greater than or less than or equal to 6? Yes, it is. So that means that region works. So what I would highly suggest is if you have color pencils, which we do in the classroom, if you have color pencils or highlighters, use that when you're answering or when you're shading in your region. So I'm going to use, actually, I'm going to use red just because it's a red graph. So here is my answer to all of my red inequality. So every single point that I pick in this shaded region would satisfy the inequality of x is less than or equal to 6. So that red region that I just shaded in there is the answer to my red graph. So now I'm going to go ahead and graph this one in blue. So now I have y is greater than -3/2 x plus 4. Once again, we're graphing it as if y is equal to -3/2 x plus 4. Our b is equal to 4 in this example, which is then going to give me 0, 4. So here's my point, 1, 2, 3, 4. And then my slope is equal to -3/2, which we know is change in y over change in x. So I'm going to go down 3, 1, 2, 3, to the right 2 because it's a positive 2. So there's our next point. Then I'm going to go down 3, 1, 2, 3, and over 2 again. And there's our next point. Now is it a solid or a dotted line? And this one's going to be dotted because it is not equal to. So I'm going to go ahead and just draw my dotted line going through my points. All right, so there's my blue graph. Now I need to figure out which region am I shading. So I'm plugging in 0 in for y and 0 in for x. So -3/2 times 0 plus 4. Well, this gives me is 0 greater than 4? And no, that is not. So that means I'm not shading the region that includes the point 0, 0. And that would be this region down here. So I'm going to shade the region above it. So everything above that blue graph is going to be my answer. And once again, now I'm looking to see, well, where do they overlap? And I see here clearly when I had the highlighters, it's a little bit easier for me to see that this region here is what shades both the blue and the red. So there is my final answer. All right. And this actually extends, because our graphs extend beyond this, with the arrow saying extend to infinity, this extends in this direction if we were to expand this graph. All right. So everything that we already learned, solving inequalities, which you guys did really well when we were answering this on the assessment. So everything that we did for this, it's just coming back right now. But now all we do is graph two inequalities on one graph. And then we look to see what our regions overlap. A lot of you, when you handed in the last question to see if you needed to watch this video or not, you forgot to shade the region. You were graphing your graph correctly, so the boundary line you're graphing correctly, but then you forgot what it meant to be an inequality, and that it's not just that graph, but it's a region that we're looking for, and we needed to test a point to see, well, which region do we shade? So that is our answer. Those shaded regions are the answers, not the line. The line is part of our answer, but it's breaking up our graph into two separate boundaries, and the shaded region is our answer. All right, so that is it for this video.